Significant digits. The digits of a number that express the accuracy of a number are called significant digits. It may be surprising, but the zeros written in a number are not always considered significant. It depends on where they're located in the number. Here are the significant digit rules. Number 1. All non-zero digits are significant. For example, 3.14159 has 6 significant digits. Rule number 2. All zeros between significant digits are significant. For example, 30,032 has 5 significant digits. There are zeros in here, but they're surrounded by non-zero numbers. Rule number 3. All zeros which are both to the right of the decimal point and to the right of all non-zero significant digits are significant. 0.00250 has 3 significant digits. The last zero is significant. These first zeros are not, because this zero is to the right of the decimal point and it's also to the right of the non-zero significant digits. Sometimes questions will ask you to round your answer using significant digits as opposed to decimal places. Below are 2 situations. Brandon and Michelle started with the same number, but rounded differently. Compare and contrast how each person rounded their answer. Alright, well they each started with this large number, 587,234.168. Brandon rounds to 2 significant figures. So this is the, right here, he looks at this number, 1, 2, second significant figure. So he looks to the right, and to the right is 5 or greater, so right, 7 is greater than 5. So then he rounds this up to 9, and then everything else just becomes a 0. So that's how Brandon rounded to 2 significant figures. Whereas Michelle, she only rounded off the 1,000th place. So she rounded to the 100th place here. So she looked at the 6, she looked to the right of it, it's greater than 5, so she rounded 6 up to 7. So Michelle rounded to the 100th place. You may have wondered, if the question doesn't specify, how do I determine the appropriate amount of significant digits when I round? It really depends on the operation involved with the problem at hand. Let's try some examples to see what we're talking about. For a sum or difference, you're going to use the least accurate place value. For example, we have 502.04 minus 84.9 equals 417.14. However, the least accurate place value was the 10th place here, so we have to round to the 10th place, 417.1. For a product or quotient, you use the least amount of significant digits. For example, we have 502.04, and that has 5 significant digits, multiplied by 84.9, which has 3 significant digits, so our answer is going to have only 3 significant digits. So we have 1, 2, 3, and then we're going to round the rest of these. Since this is a 2, this is just going to get rounded out, and we are left with 42,600, which contains 3 significant digits. So the rest of these become zeros. In your home, you're installing a wallpaper border around your bedroom. You measure the wall lengths and record them as such. These numbers right here, all in meters. Find the total length of the border that you need to purchase and express your answer with the correct number of significant digits. First, we add all of the measurements together and we get this number here. But we have to look at the numbers. We see the least accurate place value is here, 3.5. That's in the 10th place. So therefore, we have to round to the 10th place. So we see the 7, we look to the right. Because it's 5 or greater, we're going to round that 7 up to an 8. And so our answer is 80.8 meters. You measure a box that you need to fill with a liquid. Its length is 4.9 centimeters, its width is 4.7 centimeters, and its height is 3.6 centimeters. Calculate the amount of liquid it will take to fill the box. Express your answer with the correct number of significant digits. The question is asking us to find the volume of the box. Now the volume of a box is length times width times height. So we multiply all of these numbers together and we get 82.908 cubic centimeters. Then we look and we see that all of these numbers have two significant digits. So therefore we need there to only be two significant digits, which means right here, these two. Now do we round up? So we see a 2 here. We look to the right. Because 9 is 5 or greater, that means we are going to round that 2 up to a 3. The answer is 83 cubic centimeters.